Arijith, I am recording my class regarding your doubt which you have asked in the WhatsApp yesterday morning. Today I couldn't get up, sir. Actually, my mother went and she usually wakes me up in the morning, but I couldn't get up on my own. But still, I am recording this class. You can hear after coming from the college. See, in this question, you should know one thing. You can solve this question either in restoring force method or energy method. I'll explain both. Before understanding this question, you should know how much is the extension in spring when the block M moves by distance x. So first of all, this whole system will be in equilibrium because weight will be downward, spring force will be upward, and the whole system will be in equilibrium. Now, main thing what you have to understand is, let's talk about equilibrium position. I am only talking about case A, Arjit. In equilibrium position, what all forces are acting? See, if you see in the case A, there is pulley P. So this side the spring is attached and this side only thread is there, and down there is mg. Now this side there will be some extension in the spring, so therefore the tension will be kx0. Let's say the initial extension in the spring is x0. Now since it is the same thread which is connected all throughout the pulley, whatever tension is there on the left hand side, the same tension will be there even on the right hand side of the string. Therefore at equilibrium position, 2kx0 is equal to mg. This should be very clear for you. What is happening in equilibrium position? Okay, now if this is clear, I will go for the further explanation. Let me first use force method, restoring force method. For that, we need to know, wait a second. See, call this point as point A. Sir, if point A, this is only for example I am saying, if point A moves down by 10 centimeters, then pulley moves down only by 5 centimeters. Why this happens? Sir, very simple. Spring got extended 10 centimeters. Then in that 10 centimeters, 5 centimeters will be used for, 5 centimeters of the thread will be gone for other side to extend its length, and another 5 centimeter will be used for lowering the pulley. Got this? How I'll explain, one second. So let's say right now the spring is like this and pulley is attached. You have got here some A centimeter, not A, let's say P and P length, both sides. Now spring got elongated by 10 centimeters. Then what happens? On both sides, it will become P plus 5, P plus 5, and this lowering of the pulley will be another 5 centimeters. Because why this distribution of 5 centimeters to the right hand string and the mass is happening? Because on both sides you should have the equal length. If 10 centimeters increased in the spring, then to make it equal on both sides, 5 centimeters should be given to right hand string and 5 centimeters to the pulley. Then only properly that this side thread length and this side thread length will be equal, then only there will be, that is what is happening in the reality. I think you understood. Therefore, if spring extends by z centimeters, then pulley lowers down by z by 2 centimeters, correct? Or otherwise better I will use the variable y centimeters. If spring extends by y centimeters, then pulley lowers by y by 2 centimeters. This statement is the golden statement, please remember that. If spring extends by y, then pulley lowers by y by 2. That means reverse. Let's write reverse. If mass m lowers by x centimeters, spring extends by 2x centimeters. Same thing, y by 2, x and 2x, that's what, same thing, sir. If this mass goes down by 5 centimeters, that means the spring got extended by 10 centimeters, then only it is possible for the mass to go down 5 centimeters. I think these two statements are clear for you. Okay, so now I am erasing this. I wanted to write the force method. See here, there is also a way to prove this. There is also a way, surely. How that length will be, well, mathematical also I can try to prove that. Okay, just I will try whether mathematically it is possible to say for you that extension the spring is double the moment of the mass. Okay, let's say mass moved down by x1 and spring elongated by x2. Spring elongated by x2. How can we prove this? If okay, mass moved down by x1, it is not an equilibrium, we cannot prove it. Only way is to prove it using constraint motion. Okay, this I will find out the proof using constraint motion. Otherwise, logically speaking, both sides the length has to balance. Whatever length, let's say the spring elongated by 10 centimeters, this side the thread cannot elongate by 10 centimeter, na? So whatever elongated length is there by the spring, that has to be given to the right hand side string, so that both will have the same length. So if it elongates by 10, 5 will be given to the right hand side string and 5 will be given to the mass. Therefore, both the left hand side spring and right hand side string will have the equal length. Now, let's start doing this problem using force method. Mass m elongates by x distance, or not, instead of elongation call it as movement. Just mass m is moved from its position by x. Got it? Now if mass m moves by x, from the previous discussion, spring elongates by 2x distance. Okay, so spring is elongating by 2x distance. Now if spring elongates by 2x distance, force developed in the spring will be k into 2x. Therefore, the tension in this wire will become 2kx. K into 2x is 2kx. The same tension will be there even this side, 2kx. Okay. Therefore, so according to the pulleys which we learned in Newton's laws, 2kx is upward. So here the force will be what? Adding of those two, 4kx. Sorry. Therefore, 4kx is the restoring force on mass m. 4kx is the restoring force. Therefore, restoring force is equal to minus 4kx. And from here it is very simple. A is equal to minus 4k by m into x. So time period is 2 pi root mod x by a. So 2 pi root m by 4k. This is the time period of the oscillation. This is using force method. Now, since it is a recorded video, sir, you can pause it and note down. I am also explaining the energy method. Energy method, how to do this, sir? Very simple. In the starting of this question, I have written one thing, that 2k x naught is equal to mg, right? So from where this 2k x naught is coming, sir? In the initial state, when right now the diagram what they are showing is an equilibrium position, means you are not disturbing the system. When you are not disturbing, spring will elongate some distance to balance the weight. So let's say the spring elongated by x naught. Then if it's elongated by x naught, tension is kx naught. So 2k x naught downward will balance the weight. This is the first conclusion. I think it's clear. Now let's say the mass has been moved down by distance x. Then we know that spring will elongate by 2x length, right? Now let's write the energy of the whole system. Mass has moved down by distance x, therefore the decrease in potential energy is minus mgx. And since it's moved down, it will get some velocity. Half mv square is the kinetic energy of mass m. Now the potential energy of the spring, half k into, already it is having an x naught elongation. Along with that, since the mass m has moved down x length, the spring will elongate by 2x length, is equal to total energy. I think this is clear. Now you have to differentiate it. Minus mg into differentiation of x will give you velocity, half mv square. So 2 will get cancelled. mv into differentiation of velocity is acceleration. Next, half k into the differentiation of x naught plus 2x will be 2 into x naught plus 2x into differentiation of x naught plus 2x will be 2v, which will be equal to 0. 2 cancel. Everywhere v will get cancelled. So you will be left out with minus mg plus ma plus 2k x naught plus 4kx is equal to 0. If you observe carefully, 2k x naught is equal to mg. Therefore 2k x naught and mg will get cancelled. Now ma is equal to minus 4kx. A is equal to minus 4k by m into x. We came to the same conclusion. Right? So even using force method or energy method, we came to the same conclusion. Just a second. Arijit, I got the way to prove using constraint relations, which we have done in Newton's laws, the pulley problems. So in the first question, what we told is, if mass m lowers down by 5 centimeters, just for example, spring has to elongate by 10 centimeters. That is what our conclusion, and let's prove it. I am erasing this diagram cutting. I'll explain it later. See it here, since spring is there, to apply constraint motion might be little difficult. Therefore, what we will do is, let's take up this point as point A and point B. If you observe carefully, Arjit, this length of string is always having the constant length. That you cannot change. That length from point A to this point is always constant. And when you are pulling the mass m, this length is not increasing. It is getting the extra length from the extension of the spring. Therefore, from A to C, you can apply the constraint relation. How to apply? Because it is a constant length. Let's say from the ceiling, the length of point A is x, and from the ceiling the length of point B is y. And now if you want to take the length of the string, the AB length plus BC length is always constant. AB length is y minus x and BC length is y is equal to constant k. So 2y minus x is equal to constant. Now differentiating on both sides, 2 dy by dx, no, not x actually, you should differentiate with the time. 2 dy by dt minus dx by dt is equal to 0. So dy by dt means what? Nothing but velocity of point B. Point B velocity is nothing but velocity of mass minus dx by dt. The elongation in the spring, nothing but velocity of point A is equal to 0. So 2 times velocity of mass is equal to velocity of point A. Means if mass moved down by 5 centimeters, the point A will come down by 10 centimeters, nothing but elongation in spring. This should be very clear for you. This is how in the first problem we got that if mass moves down by 5x actually, then the spring will elongate by 2x. This is the proof for that. Now going to B bit. In B bit also we can apply constraint motion to know what is happening. See in B bit, this length of the wire is always having the constant length. So let's call this point as A, B, C and this one D. Let this distance be equal to x and this distance let's call it y and this constant length let's call it z. So length of the wire will be AB plus BC, which is equal to some constant k. Now AB length is nothing but z minus x. BC length is nothing but y minus x is equal to k. So z plus y minus 2x is equal to k. Now differentiating, you will be getting dz by dt plus dy by dt minus 2 dx by dt is equal to 0. Sir, z is the length between ceiling to the ground, so there will be no change, therefore this value will be 0. Now what you got? Dy by dt is equal to 2 dx by dt. This is the constraint relation we got. Dy by dt is nothing but velocity of mass and 2 into dx by dt is nothing but velocity of point B, nothing but elongation in the spring. Means what we can understand from this statement, if spring elongates by x centimeters, mass m will come down by 2x centimeters. That is what this statement come meaning. I think it is very much clear for you using constraint motion. Sir, you can see it repeatedly. Since it is a video recorded, you can pause the video and you can also see it. So now what I'm going to do is, let's say mass got stretched by x distance. Therefore, mass got elongated by x distance. From the previous constraint relation, what we can understand, we got na previous constraint relation. What did we get? One second, I'll just I have erased it kada. Here Vm is equal to 2 times V into B. Okay. Let me put this, only erase. No. I will not erase this one. I'll erase this part. See here. If mass m comes down by x centimeter, then spring elongates by, see reverse of this statement, spring elongates by x by 2 centimeter. I think it is clear for you. Just opposite of this. Now the restoring force, since spring elongated by x by 2 centimeters, the upward restoring force is kx by 2. According to the logic, here there will be some tension, here there will be some tension. So 2t will be equal to kx by 2, tension will be kx by 4. Therefore, restoring force in the mass m is tension. So F is equal to minus kx by 4. Okay. So acceleration is equal to minus k by 4m into x. Time period will be 2 pi root x by a. So 2 pi root 4m by k. This is the time period in the second scenario. Arijith, I think this question is completely clear for you. The nice question what you have asked. Please see this video before today's class.